Thanks everyone for attending. My name is Brad Llewellyn, and what I focus on is really helping people find ways they can use technology to solve their problems. And today we're going to talk about that in the lens of data science. Before we do that, I'll give you a very short snippet about who I am and why you should care about what I'm saying. So I'm a senior consultant at an organization called SYNTELLI Solutions. We are a data science consultancy in Charlotte, North Carolina, and we do a lot of the different things that we'll talk about today. So if you hear things that interest you and you live in the Charlotte area, reach out to me and we might be able to talk. I have the whole alphabet soup of Microsoft certifications over on the side. For those of you that are either new to your careers or somewhat stagnant, certifications are a great way to accelerate your career, and I highly recommend them. In fact, Microsoft's got some of the best certification programs in the world, so definitely look into that. I've been an analyst consultant for probably 5.5 years at this point. I've been at SYNTELLI for less than 6 months now, just started back in February. If you like what you hear today and you want to learn more about these types of topics, I do blog at breaking-bi.blogspot.com. You can see it right there, or you can reach out to me on Twitter, LinkedIn, or by email. I'm also I'm a huge advocate of community involvement. Another thing you can do if you're looking to advance your career or even just to get a little bit more satisfaction out of your career, community involvement is a great way to do that. Like Jason said earlier, every single past virtual group is looking for speakers. Not only that, they're looking for volunteers as well. So people who can help coordinate these sessions, whatnot, as well as I can assure you that there are local user groups somewhat near you that are focusing on the same things. So find some way to get involved in the community, and I promise it'll pay off. Personally, I am one of the organizers of a group in Charlotte called the Charlotte PI Group. We meet on the first Tuesday of every month, and we talk about a lot of the topics we're going to hear today, things like Power BI and SQL Server and Azure Machine Learning and stuff like that we talk about. So if you're in town, come check us out. I'm also a frequent member and speaker around the PASS community, and I can't speak highly enough of the PASS community. So please get as involved as you possibly can here. There's tons to learn and tons to do. I do want to give a specific shout out to the PASS Cloud Virtual Chapter for having me this time and letting us all get together and talk about these topics. These groups really do give us an opportunity to come together and learn interesting things. So I highly advise for those of you that if this is your first PASS webinar or if you're an infrequent attendee, that you check out pass.org and see what else is going on. I know that they have many SQL Saturdays and PASS Summits coming up. So with that, let's get on to the meat of the demo, or the meat of the talk here. So throughout this talk, we're going to look at a number of different ways to really answer this question. So this is the core business question that every business leader wants to answer. And that question is, what's the easiest way to solve this business problem? Notice I said business problem. It's very common for those of us in the tech field to focus on technical problems. How do I speed up my SQL Server queries? How do I get more accuracy out of my machine learning models? How do I do X? Throughout this presentation, we're going to step into the shoes of being consultants. And as consultants, it's important for us to identify where the value in things is and how can we ensure that what we're doing technically aligns with those values. So with that, let's talk about what a customer's primary concerns are. We said easiest way. What does easy mean? The number one concern for every customer on every project I've ever worked on and any project I've ever heard of is always, will this solution actually solve my problem? At the end of the day, if the solution doesn't solve the problem, then it's not an actual solution. On top of that, the next most common concern is, okay, this will solve my problem. How much is it going to cost to implement it? Am I going to have to spend $500,000 to implement it, or can I do it for 10 grand? Those are very different solutions. Also, how long will it take? In organizations and enterprises, time is money as well. So time goes right along with cost when we look at implementation. Something that doesn't often get considered when we look at cost of solutions is not just how much does it cost to implement it, but how much does it cost to maintain it. When we look at cloud resources or Azure in particular, products have a defined cost over time. So just to keep a SQL server running costs X dollars. There's also less accessible cost. For instance, the cost of hiring and maintaining staff to do particular things. So hosting an on-premises SQL server might be more expensive than utilizing an Azure SQL server because the cost of having to have people to maintain the on-premises server might outweigh the cost of just having Azure do it for you. So that's part of the decision-making process as well. And finally, while this is the concern everybody talks about, it's actually last on my list of concerns. It's an important concern, but not top of the list. And that's how quickly does it adapt to changing requirements? This is that agility and flexibility and extensibility we talk about. One thing that's true in every single enterprise I have ever seen, every project I've ever worked, the requirements on day 90 are not the same as the requirements on day 1. Something changed, and our solutions need to be flexible to that. So, with all that in mind, let's talk about some of the tools we're going to look at today. The first tool we're going to look at is Power BI. Then we're going to branch to something very different called Cognitive Services. We're going to leap again to something also different called Azure Machine Learning Studio. And then we will bring all of those together into the 800-pound gorilla, as they call it, of R, Python, and HDinsight. All of these tools, if you will, all of these resources belong to a suite of tools called Cortana Intelligence Services. It is a logical grouping of Azure resources focused around data and analytics. So all of these tools approach basically the same types of problems, quote-unquote data science problems. Generally, in my talks, I like to define what data science is up front, or at least what I mean when I say it. However, in this talk, we're going to take advantage of the ambiguity of that term. Every time I talk to a customer about quote-unquote data science, they all think it means something different. That's the universal fact is nobody agrees on what it means. So one of the important things for us to do is dig beyond the buzzwords and really understand what a customer's requirements are. And once we identify what the requirements actually are, what problem the customer is trying to solve, then we can start talking about which of these tools might be a good solution for them. So before we get to any of the tools specifically, why don't we take 60 seconds to read an introduction to our company. So this says that Contoso Beverage Company, also known as CBC, is a large beverage distribution company in the United States. Their main source of revenue is selling cases of soda, tea, and other beverages to customers all over the world. Customers can place orders using CBC's intuitive website. CBC also sells and services fountain beverage machines. However, this is a separate branch of the business that only takes orders over the phone. So a few things to point out here. One, we're selling beverages. We're selling beverages to either regular customers or other businesses. We can sell those over a website, and that website will be important later. Also note that we have a completely separate branch of the business that sells and services the fountain beverage machines. And it's important to note that that branch of the business takes their orders over the phone, which implies that they might not be as technologically advanced as their counterpart. And that'll be important too. So let's look at our first tool. First possible tool for Power BI, for a data science, quote unquote, solution, is Power BI. So what is Power BI? Over here on the right side, we have a Power BI report. And Power BI gives us a data analytics or reporting interface. It's what used to be known as self-service BI. I don't hear that term too often anymore, but it's still effectively the same thing. And it can be deployed in cloud or on-premises infrastructures. So looking over at the picture on the right side, we see this is a tool that's very good for showing people information visually. We're not doing a ton of deep analysis here. We're not building regression models or anything, but it does give us the ability to say, what did I sell? Who did I sell it to? You know, where am I seeing my issues? Also, one thing we will see throughout this talk is that Power BI, while we won't demo it, is a very easy tool to use. It's got a very nice drag and drop interface that makes it accessible to business users and data professionals alike. So with that, let's look at our first business problem and think about why Power BI might be a good solution to this. So this says, CBC offers a lifetime warranty on all the fountain beverage machines they sell. The engineering team wants to perform quote-unquote data science on their data in order to find out which types of machines they should be selling and who they should be selling to in order to reduce their repair costs in the future. This data is currently stored in multiple Excel files on the manager's laptop. This is a common business problem that we see, but a lot of this is unnecessary information. As effective consultants, our job is to whittle away at all the unimportant stuff and really dig down to what are the requirements here? What's the actual problem? So, oh, my mistake. Let's backtrack 1 second. With that business problem in mind, the question we need to ask ourselves, and we'll ask ourselves this question multiple times throughout this presentation, does this actually solve the business problem? Is Power BI a good solution here? In order to determine that, let's dig into the problem, like we were saying before. So the first thing that sticks out to me when I read this, and you may have different things that stick out to you, is this line, which types of machines they should be selling. So they want to be able to identify particular machines. They also want to be able to identify particular customers. So which types of machines and what customers? How do they want to identify them? They want to identify them in such a way that they can reduce their repair costs. And finally, data storage is a very common requirement to look at. So here we see that the data is stored in multiple Excel files on the manager's laptop. So letting everything else fade away, this is our problem. We want to know which types of machines to sell and who to sell it to reduce repair costs, knowing that our files are in Excel. So with that, let's look at why Power BI might be a potentially good solution to this problem. First, let's look at that first set of requirements we found. So these, when I first hear them, and we don't have full context here, we have a paragraph of information. This sounds to me like a good use case for some basic reporting. One of the questions we often ask customers whenever they say, oh, I want data science, I want you to predict who I should be selling to, or I want you to predict which types of machines I should be selling. The first question is almost always, how do you see this information today? No, what do you use this data in your daily decision making or not? And sometimes they come back with the answers of, oh, well, we've never really looked at this data. So a good first step there is self-service reporting and analytics. Saying, okay, why don't we just look at this data? Why don't we just see at a high-level glance using a tool like Power BI? Let's start slicing your repair costs. See, do you have any customers that have extremely high repair costs? Maybe you shouldn't be doing business with those customers. Or maybe you should identify what's going on at those customers that are causing them to have extremely high repair costs. For instance, you might have some customers that are utilizing an outdoor fountain machine, and the weather outdoors is just killing the fountain machine. So you might go in and move their fountain machine indoors for them to reduce the repair costs. You also might have certain types of machines that break down really often. And you could find out that the manufacturing process for those machines might be suboptimal. And there are some gains you can find there just by manufacturing a higher quality item there to save money in the long term. You can answer all those basic questions just using a tool like Power BI. With that in mind, the next requirement was about data storage, those multiple Excel files. So depending on what data storage mechanism you're using, Excel may or may not be a good choice. For instance, a lot of the common ETL tools don't like Excel very much. They can do it. You can absolutely ingest Excel files through SSIS, but it's not nearly as clean and elegant as ingesting from other databases or whatnot. Power BI, on the other hand, loves Excel. It really has no problem. In fact, you can do automatic updates in Power BI easily. And on top of that, business users can do that pretty easily. Power BI's got a nice interface. Click Get Data, and voila, your data's in your Power BI report. This adds a lot of flexibility because oftentimes when we see customers that use Excel files, they probably don't have a good data governance or data lineage processes to really manage that data. So giving them a really flexible tool that they can handle themselves might be a good use case. Also, some additional points about Power BI that don't directly tie to the requirements. One, since Power BI has such a small learning curve and such an easy-to-use interface, it's often very quick to implement things. You can go from having Excel files to having a Power BI report in an hour, literally an hour. You can go develop enterprise-grade reporting off of Excel files in days using Power BI. On top of that, Power BI has a very low cost of ownership. Power BI is $10 per person that wants the pro license, meaning they want to be able to share data around their enterprise. However, for a POC use case like this, if you just want one or two managers that want to see their data and mess with it on their own, Power BI is completely free. You can download Power BI Desktop right now for absolutely nothing. Additionally, looking at the long-term growth of this, if these Power BI reports take off and everybody loves them, they might need to hire professionals to build and manage these reports for them. In that case, Power BI skills are very easy to find in the market. Easy to find means, one, spending less time hiring, and two, it means the resources you hire generally don't cost as much. You don't need six-figure resources to develop Power BI reports. So with all that in mind, we take a breather and really think about what we just talked about. So Power BI is a potential solution to a use case like that, where you have a branch of the business that may not be super technologically advanced. They may not have existing reporting, and they may not even have a data team or an IT team to actually manage anything for them. In those cases, Power BI is a great decision. Is it the best? I don't know. We're not here to say this is best versus not. It's just looking at our options. So with that in mind, let's look at another option. Let's look at a set of tools called cognitive services. So with that, what is cognitive services? Cognitive services is a collection of 28 pre-built machine learning algorithms available in Azure, and they're trained using Microsoft's data. If we look at the bottom of the screen here, we see five big words: vision, knowledge, language, speech, and search. Those are the 5 categories of cognitive services algorithms. So for instance, cognitive services has algorithms for facial detection. You can feed a picture into the API, and it'll send you back how many faces it finds and where the faces are. And it'll even give you information about those faces, like this is a female, expression is frowning, and things like that. They have different knowledge APIs you can utilize, and they've got language. Some of their common language APIs are around translation or sentiment detection. Also, they have speech APIs that can convert audio into text and do speaker recognition and things like that. Very, very powerful. As well as they have Bing search APIs that you can use to programmatically search for things. So if you had a tool that needed to be able to integrate search functionality directly off of the web, then the Bing APIs, a way that you might potentially do that. It's important here to note the last line, trained using Microsoft's data. This is really important. There are a lot of enterprises out there. We'll exclude the really high-end enterprises. So exclude companies like Microsoft, like Google, like Amazon, or those other gigantic companies. The majority of enterprises that have data science teams don't invest a ton of money into it. They might have 5 people, 10 people, 20, 30. Microsoft almost assuredly has more data scientists than your organization. It's a virtual guarantee. On top of that, Microsoft has access to Bing and Cortana. That's a wealth of data that your organization also likely doesn't have. So that combination of tremendous investment in data science programs, as well as a wealth of data at their disposal, means that their pre-built machine learning algorithms are almost guaranteed to outperform anything you could ever build in-house. So as long as your problem fits in one of these 28 pre-built machine learning algorithms, one potential option there is use the pre-built algorithm. Don't build anything in-house. So let's look at a potential business problem that might fit that. So this says that CBC's website allows customers to leave comments about their orders. The customer service team wants to perform quote-unquote data science on their data to find out which types of customers and or orders tend to leave negative feedback. This data is currently stored in a SQL Server table. So with that in mind, we come back to well, we used to have a slide there that had the same question again. My mistake, but go back to the question again of, does this solve the business problem? Is cognitive services a good solution to this business problem? And without giving away the answer, yes, there it is. Okay. So let's break down this business problem and try to understand whether cognitive services is a good solution. So first thing I see when I look at this is they mentioned they have a website. Like we said before, that's important. As data professionals, we have a certain set of skills. Website developers have a very different set of skills, ones that we might be able to utilize in some scenarios. Also, they want to be able to find out which types of customers and or orders tend to leave negative feedback. And this data is currently stored in tend to leave negative feedback. And finally, this data is stored in a SQL Server table. So letting the rest of this fade away, we're left with their website. They want to find out which types of customers and or orders tend to leave negative feedback. So we want to be able to identify customers and or orders, if possible, down to the customer and or order level. An important word next here is negative feedback. What does negative feedback mean? whenever these customers write their comments onto the web, not like they select a button that says, hey, my feedback is negative. So what's likely sitting in this SQL Server table is just text of people writing things. So we need some way to identify whether that feedback is positive or negative. So with that, let's answer why cognitive services might be a good solution here. First, we look at the two items around technologies. So they have a website, and this data is stored in a SQL Server table. What does that mean to us? Well, cognitive services is available as Azure APIs. So you can go out to Azure right now, and you can spin up some instances of these APIs and start calling them however you need them. As data professionals, APIs may or may not be easy for us to work with. For instance, there's no way to, or there's no simple way to just directly call an API from SQL Server. You can't just write select star from API. However, we have a website. A website means we have web developers. APIs are very common in the web development space, meaning that we definitely have the skills on hand to integrate those APIs in some way. So we don't have to go out and hire new people. We can use the APIs exactly as they are. Additionally, we had the concepts of being able to identify the customers and/or orders and identify negative feedback. So as we said before, cognitive services has these pre-built algorithms that don't require data or training. One of those pre-built algorithms is a sentiment analysis algorithm. You can feed it text, and it'll feed you back a score of whether it's positive or negative. Almost exactly like what we need. Also, we can feed it the individual comment. You can say, this person says, this is the greatest product I've ever had in my life. Feed that exactly to the API. The API will send it back saying, this is positive feedback, and you'll know exactly which customer that came from. So we can tie it directly to the customers and or orders that receive that feedback. And we could, if we wanted to, even go backwards and implement Power BI on top of that. Or any other reporting solution saying, oh, now we can combine these two to understand these are the types of customers and or orders, and this is the amount of positive or negative feedback that we're getting for those. In addition to that, and you probably recognize this text because it's exactly what we saw before, probably noticing a trend at this point. Cognitive services being pre-trained and being easily accessible as Azure APIs, they're very quick to implement. You can, assuming that you know how to access an API, you can get these up and running in hours easily. Also, if you use the APIs efficiently, they have a very low cost of ownership. If you do silly things like running your entire database against the API nightly, you're definitely going to incur some large costs that way. But if you just do certain comments or just do new comments or things like that, you can really keep your costs low on a solution like this. Also, you don't have to buy any new hardware or any new tools, so you get that efficiency as well. On top of that, the skill set of being able to utilize APIs is very common in the industry. Like we said, every application developer in the entire world knows how to do that. That's a core requirement of that job. So you can find those skills very easily. In fact, you often find that a lot of DBAs have those skills too. So we can easily find those skills as our project grows. So with that, we take another breather and think back to what we've seen. We've seen that for less advanced customers who really just want to start looking at their data, they may say the word data science, but really what they're looking for is standard analysis. Power BI might be a good tool for allowing them to start visualizing their data, start playing around with it. If we have customers that want predictions, want machine learning models of some type, or even advanced analyses like sentiment analysis, cognitive services could be a good fit if our use case fits one of their pre-built algorithms. Granted, those pre-built algorithms are relatively narrow and they don't cover all problems, but if they do cover your problem, they're also potentially a good solution. With that, let's branch out a little further. Let's start talking about Azure Machine Learning Studio. This is a personal favorite of mine if you've seen any of my other presentations. So, what is Azure Machine Learning Studio? So Azure Machine Learning Studio is a tool designed for machine learning and data analytics. As we can see on the right side, it has this fully drag and drop interface. So that makes it very easy for people to use, and we'll touch on that again in a minute. Also, it's an entirely cloud software as a service, meaning you just go to, you can either Google Azure Machine Learning Studio and sign up for a free workspace, or you can go to your Azure subscription and sign up for a paid workspace there as well. Either way, it's entirely up in the cloud for you to use. You just go to a website and it's there. You don't need to worry about any hardware, any configurations, anything like that. Also, looking over on the right side, we see it has a very comfortable feel. It's another one of those tools that's easy for people who may not be professional data scientists to use, or at least traditional data scientists. I've got a whole other talk where we define that term. So in this tool we see on the right side, we've actually created a linear regression algorithm using just a drag and drop interface. So this really gives us that ability to, assuming our problem is quote unquote simple enough, and we won't talk too much about what that means, but most business problems I've found can be in some way, shape, or form at least approached using Azure Machine Learning Studio. So it's a good starting point for identifying how difficult a problem is. Now, with that, let's look at another business problem and think about why Azure Machine Learning Studio might be a good solution here. So this says that CBC's customer churn rate has been steady for the past 3 years. The account management team can see this information using their existing set of reports and dashboards in Power BI. They want to perform quote-unquote data science to develop an algorithm for predicting when particular customers are likely to churn. They will use this information to reach out to these customers and attempt remediation. This data is currently stored in a SQL Server data mart. So, the same problem we've asked ourselves multiple times. Does this solve the business problem? Well, let's really break into the requirements and see. So, the first thing that sticks out to me here is they have an existing set of reports and dashboards in Power BI. Remember, back in the Power BI section, we asked ourselves an important question. The important question was, are they already visualizing this data? Have they actually looked at this data? So if I was to go into this customer and pitch them Power BI, oh, Power BI is going to solve your problem, they're going to look at me like I'm crazy. We're already using Power BI. Power BI is obviously not the answer here. So maybe we need something a little bit more advanced. They also are saying that they want to predict when particular customers are likely to churn. So exactly this person is likely to churn, not these types of customers churn, or not customers churn on these days, but this particular customer is about to churn, do something about it. To reiterate that point, they want to be able to reach out to those customers and attempt remediation, which means we must be able to identify the individual customer. And this data is stored in a SQL Server data mart, meaning that they are relatively advanced. They are, at the very least, capable of doing basic analysis on their data without our help. So, drowning out everything else, this is our problem. Let's break it down and see why Azure Machine Learning Studio might be a good solution to this problem. Now, first, as we mentioned, they already have a SQL Server data mart and Power BI. So coming back to them with the basic analysis solution of why don't we put it in SQL Server and put a Power BI on top of it, probably not going to fly here. It's either going to offend the customer or it's just not going to solve their problem at all, or both. So why is Azure Machine Learning Studio a good solution on this? First of all, it is a little bit more advanced than Power BI. It does give us those innate ability to create machine learning models, create actual predictions. And it does that in a way that's accessible to data professionals that have minimal machine learning experience. That means that they already have this set of Power BI developers. They already have these SQL developers. They already have DBAs and data analysts. They could potentially use the tool to solve their problem, meaning that we're not leaving them with a tool that they can't use or have to hire new people or have to write a support contract with us to come help them forever. On top of that, Azure Machine Learning Studio supports limited use of SQL, R, and Python. So if they do have, well, they definitely have SQL skills, but if they do have R and Python skills available, even in small amounts, they could potentially extend the use of Azure Machine Learning Studio with that. Also, we can easily deploy and access these solutions using Azure APIs. That gives us a lot of cost savings around deploying these solutions, which can sometimes be a problem. And as we mentioned before, they have a website, so APIs should not be a problem for them. Finally, we're getting down to being able to predict particular customers. Power BI is great at showing us rolled up information. Can we use Azure Machine Learning Studio to predict particular customers? So as we said before, Azure Machine Learning Studio creates targeted machine learning models. You can create classification models that say this customer has an 80% chance of churning in the next 3 months. You can create that using Azure Machine Learning Studio. So that really gives us a potential solution for approaching those types of problems. And finally, same text we've seen before. Quick implementation timeframe. Azure Machine Learning Studio, since it's just a web interface, we don't have to configure anything ahead of time. And the drag and drop interface makes it very quick to implement. On top of that, Azure Machine Learning Studio is by far the cheapest tool we've talked about yet. It costs $10 per person, just like Power BI does, except if you're doing like a POC use case or something like that, you can use a free experiment. You can Google Azure Machine Learning Studio and it'll be completely free. If you do have to pay for it, if you do need the advanced scaling and that sort of stuff, it's $10 per user of the Azure Machine Learning workspace. And the only people that use the machine learning workspace are the developers. So you only have a few of those versus Power BI that you have to pay for everybody that uses the reports. There is some cost around using the APIs as well. So if you productionalize it, that does incur some cost, but that's generally relatively inexpensive as well. So one thing missing here is the ease of finding this skill set in the market. Azure Machine Learning Studio is more of a niche offering. I personally think it's amazing, but not all of the community agrees with that statement. So it may not be easy to find people with Azure Machine Learning Studio experience directly, but oftentimes you can make that up with a combination of your existing data professionals and maybe hiring one or two traditional data scientists that have R or Python experience. That also gives us a good next steps plan for maybe moving them out of Azure Machine Learning Studio and into even the harder tools once they have harder problems. Speaking of harder tools for harder problems, let's round out this talk by talking about R, Python, and HDinsight. So far, we've talked about 3 tools that all had those same 2 things in common: low cost of ownership, quick implementation timeframes. But all of those kind of had caveats along with them. Power BI is great for visualizing your data, but it's really not good for building machine learning models. If you need to make actual predictions, it's not great at that. Cognitive Services is amazing if you fit in its niche use cases. Azure Machine Learning Studio is also great, but only if your problem is, not up to a certain level yet. So what about the rest of the space? What about that remaining 20% or so that is just hard problems? We need tools to handle those as well. So let's talk about what R and Python are. So R and Python are both data science programming languages. As we see on the right side, that's code. For those of you that are interested, the top picture is R with the require and the deployer inputs and things like that. And the bottom with the import statements is Python. So these are the two most common programming languages out there, right? Most common data science programming languages out there right now. And Microsoft has made a lot of investments in allowing you to use R and Python in a lot of different environments. So SQL Server allows you to use R and Python, depending on your version. It hasn't quite made it to Azure SQL Database yet, but it does work in Azure SQL Server on VMs. The Azure Machine Learning Workbench supports Python, if that's the route you want to go, as well as the Azure Data Science Virtual Machines have notebooks that you can use R and Python in, as well as some of the big data tools like Azure Data Lake Analytics and HDinsight. Speaking of, what is HDinsight? So HDinsight is Azure's implementation of Hadoop. So Hadoop is the ubiquitous big data framework right now. I don't think I've ever seen a big data framework that wasn't HDFS on the back end. HDFS meaning Hadoop Distributed File System. So Azure got in on that game and said, we really want to be able to leverage the power of Hadoop, so they built their own version of it. And they built it as a platform as a service, kind of sort of infrastructure as a service. It navigates that middle ground. And the reason that's important is if there's anybody in this webinar who's ever tried to install a on-premises Hadoop cluster, it is nothing short of a nightmare. It requires extremely highly paid professionals doing a lot of work to even get it up and running. It is a nightmare for all intents and purposes. So a lot of the cloud providers, Microsoft included, have built their own PaaS or IaaS versions of this that really takes a lot of that off our plate. Instead of having to spin up a dozen Linux VMs and configure them all and define control nodes and worker nodes and everything, we just click a few buttons, give it names and usernames and passwords, and Azure does the rest. 20 minutes later, we've got an HDinsight cluster. In fact, they come in 7 different flavors. If you want to do research more into Hadoop, there's different platforms, if you will, different distributions called Spark and Storm and Kafka and things like that. So those are different use cases for different types of problems, like streaming problems or big data batch problems. On top of that, they have a first-party vendor called Databricks that basically spins up an easier-to-use version of HDinsight for you. You pay a little extra for it, but they do some of the management for you, which is a nice option. And the big point here is HDinsight is almost infinitely scalable. You can create hundreds of nodes in HDinsight to handle even the largest of workloads. But the downside, looking on the right side, Hadoop is not as mature a product as some of the SQL products, meaning it's more difficult to develop in. And those development languages are, there's quite a few of them. You can use Java, you can use Python, you can even use R sometimes. But a lot of the times use a language called Scala, which is not the most friendly of languages. So with that in mind, let's look at a business problem and think about why R, Python, and HDinsight might be a good solution here. This says that CBC's online sales system contains 10,000 different products and processes over 1 million orders per day. The marketing team would like to perform quote-unquote data science to recommend additional products to their customers while they use the online system. This data is stored in an Azure Data Lake store. No. Same question again. Does this solve the business problem? Let's take a look. So the first thing that jumps out to me here is 10,000 different products. That's a lot of products. On top of that, 1 million orders per day. So would we want to build a machine learning algorithm that looks at the cross product of those two? 10 billion combinations every day. we want to be able to recommend additional products. That means that we would need to look at that 10 billion combinations per day and then present that to the user to recommend, here's the best product or here's the top 3. Also, it needs to do that while they use the online system, meaning it can't rely on nightly batch processes, and it needs to be fast enough that the user doesn't notice, meaning that instead of 60-second windows, 5-minute windows, we need to get this thing down to millisecond windows. That's a challenge. Also, this data is stored in an Azure Data Lake store. As we've seen from the number of products and the number of orders, this is going to be a lot of data. And the fact that it's stored in Azure Data Lake store means that there is definitely a lot of it. So we're going to need something very powerful to chunk through this. So, taking all that away, here's our problem. Let's look at why R, Python, and HDinsight might be a good solution to this. So, first and foremost, we want to be able to recommend additional products. That's the core of what they're asking for. This is a very common problem that Amazon has been solving for the past 10 years or so. The issue here is that Azure Machine Learning Studio personally doesn't do a great job of product recommendations. It also doesn't scale very well. So we might need something with a bit more breadth of algorithms. And between R and Python, you have almost every imaginable algorithm that's ever been built by anybody. So we can solve any number of difficult problems using R and Python because of their open source nature and how much the community's invested in them. It also gives us access to deep learning libraries. While those might not be necessary in this case, deep learning libraries are becoming some great new tools we can use for very, very difficult problems. So with that, the other part of this problem was they had 10,000 different products, 1 million orders per day, and all this needed to happen in milliseconds. So we have to be able to do massive amounts of processing in a streaming fashion, something that SQL Server is just not great at. With that in mind, HDinsight, depending on your configuration, can consume these massive amounts of data. It can churn through 10,000 different combinations of products for a person instantly and then send you the top 3 results. You can code that depending on your configuration and how you build your R or Python code. In addition, some of the other points that are important. If we use R and Python on top of our HDinsight clusters, we're creating a single set of tools for the data scientists to use. So depending on our problem, we may want to solve it using HDinsight. We may want to solve it inside SQL Server. We may want to solve it inside Power BI. So if we're using a tool like R, we can do it in all those places. Python can be used in SQL Server or HDinsight as well. So it really gives us that environment where we can hire one set of people, one team, to solve these problems no matter where they need to be solved, which has a lot of efficiencies. On top of that, the R, Python, and Hadoop skill sets are rapidly growing in the market. So it's the issue of finding resources to do it is becoming much less of an issue now. So with all that in mind, before we open up to questions, let's have a quick review. What are we supposed to take away from this talk? If we think about our problem on 2 axes, this isn't entirely realistic, but think about it just on the 2 axes of scope of implementation, meaning how hard is the problem, and cost of ownership, meaning how much is it going to cost to solve it. The first 3 tools we talked about, Power BI, Azure Machine Learning, and Cognitive Services, are towards the bottom of this chart. They very low cost of ownership, meaning they're quick to implement and they're easy to maintain. But they don't do a lot. They do some things pretty well, but they are relatively niche in their scope. Conversely, we have R, Python, and HDinsight up in the top that they can do virtually anything. There's very few data problems that can't be solved using some combination of those 3. However, they do have pretty large cost of ownerships. It's not easy to use HDinsight clusters. It's not easy to use R or Python, not as easy as Power BI at least. And finding the people to do that often come with higher price tags, and HDinsight's a relatively expensive product on top of that. So we do get this dichotomy here. But we can think of the bottom as that fast and easy tools with the limited scope. So if you can use them, if they are the right tools for the job, you should really consider them. However, if they're not, then maybe you should consider using some of the harder tools. So with that, I bring us back all the way around to where we started. The question, what's the easiest way to solve this business problem? And with that, I'll open it up to questions. Thank you.
All right, thanks a lot, Brad. Now, at this point, we only have a single question, but I'm sure we'll probably get a question or two that comes in as as you're going through this one. But the first question we have here is how to pick and choose between Azure Machine Learning Studio and Azure Machine Learning Workbench.
Oh, that's a great question. In fact, I feel like Ginger Grant gave a talk on that about a year or so ago. But Azure Machine Learning Studio and Azure Machine Learning Workbench are two very different things. Azure Machine Learning Studio is what they call V1. It was the first iteration. And then they kind of moved away from it and moved towards the Workbench. So basically, the Studio is a very easy-to-use interface for data professionals or aspiring data scientists to really be able to solve some of the easier problems using an easier tool. The Workbench is part of an up-and-coming set of technologies that are being embraced that kind of forego the ease of use, because you do have to code Azure Machine Learning Workbench in Python. It doesn't have a drag-and-drop interface like that, but it does give you the level of power of using an open-source technology like Python. So you're trading off ease of use for complexity of problem, basically, are the two sides of that.
All right. And then also, can these be learned with an Azure subscription?
What does it mean by these?
Machine Learning Studio and Machine Learning Workbench.
Oh, okay. So Azure Machine Learning Studio and Azure Machine Learning Workbench both require you to go through the Azure portal. Azure Machine Learning Studio has a free interface that you don't have to manage the portal to do, but you can certainly purchase a workspace through the Azure portal. Azure Machine Learning Workbench uses things that are called experimentation units and experimentation workspaces, I think. They are a little bit pricier, but you do have to spin those up through the Azure portal. So if this particular attendee is interested, they can either research it on their own or reach out to me and I can provide some links.
Great. And that is all the questions that we have for today. So at this time, I think I'm going to wrap things up and thank everyone for joining us today. And thanks, Brad, for your presentation. This has been great.
Okay, thanks for having me.
All right. And goodbye, everybody.